Hey everybody, Mr. Waiter here. Last time we went over bond number and how to draw a picture of a molecule based on the formula you're given. And for homework, you were given 3 examples to do. So I've got those 3 examples up here. Those were H2O, BH3, and CCl4. And the lesson for today is step 2 or level 2 of drawing those pictures. So the first thing we need to know today is that the element that makes the most bonds goes in the middle. And that's a general rule. That's not always true because when you get to higher levels of chemistry, you have a lot more control over which elements go where. But in general, the ones that make the most bonds go in the middle, which makes sense because the ones that make less bonds can attach less times, so they can't attach to as many things, so they wouldn't be in the middle. But you'll see in a sec. So, for the first example, we've got water, which is H2O. Hydrogen, element number 1, is in group 1, so it has 1 valence electron, and that 1 valence electron is going to allow it to connect 1 time to something, and that's going to connect to one of the electrons on oxygen. Oxygen has 6 valence electrons, as you can see in the picture right here. I drew 6, and it has 1 left, which connects to the other hydrogen. So, since each hydrogen can only make 1 bond, they each attach 1 time, and since oxygen had 2 free electrons, that can make 2 bonds, so you've got those 2 bonds right here. BH3 is the same. Boron has 3 valence electrons. That's going to make the most bonds, so it's going to go in the middle. 1, 2, 3. And hydrogen can only make 1 bond. There's hydrogen 1. There's your second hydrogen. There's your third hydrogen. And then the last example I gave you was CCl4. Carbon makes 4 bonds, so that's going to go in the middle. 4 valence electrons, and each of those free electrons makes 1 bond to the free electron on a chlorine. Chlorine has 7, so 2, 4, 6, 7, and that free one is what attaches to the carbon, and you get the same thing each time. And you'll notice I'm just turning whichever electron is free towards the carbon in the middle there. Okay, so the one that made the most bonds goes in the middle. That's the same every single time. So for the new examples, we are going to try and figure out how to draw things that have more than one central atom. And this may seem a little weird at first, but it works the exact same way. So we know that carbon, element 6, right here, carbon has 4 valence electrons. That means it makes 4 bonds because each of those electrons is free. So if I draw a carbon, 1, 2, 3, 4. Okay, well, I've got 4 places I can bond things, but now I've got 2 carbons, not 1. So where do I put the other carbon? It might take you a second to figure this out, but this is going to look exactly the same as the second carbon. So I'm just going to draw the second carbon here. And just by looking at the picture, you can probably tell that these 2 dots that are next to each other are going to attach. Cool. So now we have 6 hydrogens, and if you notice, I have 6 dots that are left here by themselves. So each one of those free electrons is going to bond to a hydrogen. So there's one there, one there, one there, one there, one there, and the last one goes there. Okay, well, that leaves us with just one problem. This next example has the same number of carbons, but it has less hydrogens. So if I start the picture the same way, I run into a problem here because I only have 4 hydrogens. So if I attach these 2 hydrogens and these 2 hydrogens, I have electrons that are left over. So what do? In circumstances like these, what you do is what's called a double bond. You take the electrons that are left over by themselves and you attach those. And now carbon is attached to carbon twice. Now, I'm going to tell you right now, this double bond here that we just made is used in one of the examples. That one right there. So, your assignment for today and tomorrow is to draw these 3 pictures. You're going to draw N2H4, H2O2, and N2H2. In case you were wondering, H2O2 is also called hydrogen peroxide, so I wanted to make sure we drew something you actually knew about. But yeah, these 2 here are going to use single bonds, and this N2H2 has a double bond there. So this is going to be just like this example here. The difference is that we're switching out nitrogen for carbon, basically. And since nitrogen makes 1 less bond than the carbon does, you're going to have less hydrogens attached. Anyways, if you have any questions, please let me know, either through email, leave a comment on Google Classroom as always, and I hope this was helpful.